In question 9e, the question says to use appropriate substitution or otherwise, but I will try to do by substitution. First of all, recognizing that square root 9 is 3. So simplifying first. And we arrive at this term. Then after that, you can recognize that 3 to the power of x seems to be a common feature in the entire equation. So we will likely be using that as a substitution. Okay, but maybe before that you can change the way that it is expressed. 3 to the power of 2x is actually 3 to the power of x, then bracket square. Okay, because in this case it is x times 2, which gives us 2x. And this is 3 to the power of x times 3 to the power of 2. When I re-express this into this form by your indices law, and then we have 3 to the power of x minus 9. Okay, so at this stage, we can let u to be equals to 3 to the power of x, and we will have u squared minus u times 9 equals to u minus 9. Okay, then we arrive at a quadratic equation, u squared minus 9u minus u plus 9 equals to 0. Okay, then from here I trust that you can solve this quadratic equation. You can factorize this one, u minus 9, u minus 1. Not forgetting that you have to solve for x, not for u. So 3 to the power of x equals to 9, otherwise 3 to the power of x equals to 1. See, long make this straight up. Okay, so x will be actually equals to 2, otherwise 0. By comparing the powers. Okay. Then question 13. This one is not. For question 13, we want to simplify. Am I right to say question 13's issue is in part 1 and part 2? Am I right to say that? Some of you raise your hand, right? Question 13. Is it? So, what is the issue? Part 1, part 2, is it? Page 101. Part 1, part 2, okay. So, because part 3 is just running on part 1 and part 2. So part 1, given this, we want to show that 3x plus 4y is equals to 11. So what we need to do is to manipulate the given equation. Sorry, what am I writing here? 4y. So looking at the numbers that we're given over here, what base should we make everything to become? 2, right? So you need to have some number sense to notice that 8 can be actually expressed as a base 2, which is 2 cubed. So to the power of x from the original, and then the square root sign is actually a power of half. And then 4 is actually a 2 squared, followed by a power of y. 32 is actually 2 to the power of 5. Square root 2 is 2 to the power of half. So you change everything to a base of 2, okay, with the powers being expressed accordingly. In this case, it can be simplified as 3 times x, then times half, because of your indices law. So this will actually be 3 over 2x. This will give us 2 to the power of 2y. And in this case, it is not 2 to the power of 5 and a half, but it is 2 to the power of 5 plus half. Okay? Hence, it is very important for us to be very familiar with our indices law, which explains why I'm testing it for your class test on Thursday. Okay? Then from here, in this case, you can re-express it as 2 to the power of 3 over 2x plus 2y equals to 2 to the power of 5 plus half, that will be 11 and 2 square, 11/2. And therefore, by equating the powers, you will get 3/2x plus 2y equals to 11/2. And to achieve this, we just multiply across by 2. Okay, and we will be able to get the required equation. Okay. The same applies to question 13 part 2. With the given equation of 3 to the power of y over 9 to the power of x squared equals to 1/3 times 3 to the power of x, we should have all our bases to be what? What should all our bases be? 3, right? Okay, so 9 is 3 squared. 1/3 is 3 to the power negative 1. Okay. So simplify this, we can get 3 to the power of y over 3 to the power of 2 times x squared equals to, in this case, negative 1 plus x. Division of same base, we will get 3 to the power of y minus 2x squared. And now we can equate the powers, y minus 2x squared equals to negative 1 plus x. So you will achieve what you need. Okay. Part 3, it says hence solve the simultaneous equations. So actually they have already provided you the scaffolds in part 1 and part 2. So what you needed to do is to let this be equation 1, let this be equation 2, and then do your simultaneous equation solving. So I will not spend time on part 3. Okay? Alright, any questions? If not, let's move on to exercise 5.2. Isaac ran the question 14, what is the issue? Part 2, Question 14, part 2. You're given this formula where m refers to the mass of a radioactive substance and t is the number of days after it was first observed. Okay, so in part 2, they say find the remaining mass of the polonium-210 after 30 days. So you will just have to find when t is equals to 30. What is the value that you get over here? Okay, and then you'll be able to get answer. So I said, what is the issue? Part 2. You just replace the T with the P. Yeah. Do you read the question? Okay. So, but then maybe for part 3 you understand it correctly. You need to make sure you understand correctly. Part 3 says, hence find the mass of the substance that has decayed for 30 days. Okay? Part 1 you were looking at the initial amount of mass. Part part 2, you are looking at the amount of mass after 30 days. So in part 3, to look at the amount decayed, what you actually need to do is to find that part 1's answer minus part 2's answer. Okay? Okay, so your part 1 minus part 2, and then you'll be able to get the value. Okay? get 0.9. Okay, wait that bridge is first. Okay, so therefore, we have B equals to 60,000 e to the power of, e to the negative k is now 0.9. So maybe let me help you see it. Of t. Okay, so that's the idea. Yes. How, what? No, you shouldn't be using, there's no need for us to do natural logarithms in this case. Yeah. Your answer may not be as accurate as it. Okay, there's no need for us to do any more logarithms, which is what we're going to do next. Okay, so actually it can be just a very simple algebraic manipulation. Okay. But later on, when we learn our logarithms, you may find that logarithms is the more intuitive way of solving. Okay, but it is not quite necessary in this question. Okay. Questions? If not, can you please submit your homework to the front? You ready? Okay, ready to start? Right. For the benefit of those who were not around, okay, the last lesson, last semester, and also for the benefit of those that really didn't understand anything at all, okay, I just want to do a very quick and brief recap about logarithms. Okay, first of all, it always starts about your index notation. Okay, we are trying to change between index notation to logarithmic form. So for example, we have 2 to the power of x equals 150. This is your index notation, index form. Okay? You can call it notation, you can call it form, up to you. Right? This equation itself, clearly we do not know how to solve it. Because I cannot change 150 into 2 to the power of something. So that is the reason why we need to learn logarithms, to learn how to solve it. Okay? So 2 log x equals 150, there are certain vocabulary that we need to be familiar with. We understand 2 to be seen as the power, to be seen as the base, and then x to be referred to as the power or the index. Okay? To help us solve this equation itself, we need to transform it into a logarithmic form. So to transform it into this logarithmic form, it will mean that x equals to log 150 base 2. So if you recall how I read this, we call this log 150 base 2. Okay? So if you prefer color coding to see things better about how we change things, this is the base. It is a small number below your logarithm. Power itself being here. Now it is actually the subject. Okay? So, in essence, this is what we have touched upon in our very last lesson. Okay? And I also briefly recall going through what is common logarithm and natural logarithm. Okay, common logarithm is what we call something that has a base 10. So for example, log base 10. But usually notation wise, okay, so log base 10 there will be a number here. Usually instead of writing log base 10, we will very often write it as LG and then whatever number. Okay, so whenever I say things like LG7, okay, I will read it as log 7. So whenever you tell me log 7, log 6, log 5, log 1000, I will interpret it as you telling me that the base is 10. Okay? If you're trying to refer to a different base, you must tell me log 150 base 2. Okay, so writing in this manner, I'm referring to a base of 10. You cannot write LG7 base 6. You cannot cut short the word log. Okay, log is supposed to be a function. Okay, it is not a short form, it is not an operation. Okay, just like your fx. Okay, function fx. It is not f times s. It is a notation itself. So please don't abuse notations. Okay? So no such thing as this. This log 7 is the same meaning as log 7 base 10. Okay? Next, we also have our natural logarithm. Right here. It has a base of e. So we are looking at okay. Don't mind me the way I write my L. I'm very inconsistent in the way I write my L. Okay, sometimes I use a straight line, sometimes I use a curly L. Okay, it's just me. You don't have to be confused. Okay, it is just the letter L. Right? So it doesn't matter whether you write it as LG like that or you write the L as this. Okay? So it doesn't matter. Okay? So I just have a disclaimer that I myself is inconsistent in the way I write my L box. Okay? So natural logarithms has a base of E. Right? Instead of writing log base E, what we can instead write is ln. Okay, so an example, if you're trying to say log 7 is actually referring to log 7 base E. Okay, we generally don't write log base E, neither do we write log base 10. We will do the short form of LG and ln. Okay, this I read it as ln. I don't know how to spell the word, and it's just a word that we read. BD. You can interpret it as LON. Lon. And then this will just be referred to as log. Okay, so that's how we read it. Although maths is not an oral exam, okay, but I'm sure you will still talk to me about maths. Hence, please make sure you use the correct pronunciation for the different symbols. Okay. Questions? So, just to build on this common logarithm and our natural logarithm, right? Okay, how then do we convert between index form and logarithm form? So for example, if we have to write if I give you a logarithmic form equation as log y equals to x, to change it into its index form, okay, the base is actually a 10, power is x, equals to y. Okay, so from logarithm form into our index form. Okay, because this has a hidden base of 10, so 10 to the power x equals to 1. Just like over here, 2 to the power x equals to 150. That's what I wrote here. 2 to the power x equals to 150. Okay. In natural logarithm, if I have, let's say, ln y equals to x, I'm actually trying to convert it into index form as e. The base is e to the power of x equals to y. So always know how to locate your bases first. Okay? Once you locate your base from the logarithm, the small number at the bottom, and it will be opposite across the equation, that will be your power. That equals to this. Okay? Could you remind me, did we do try 10 before we cross borders? Maybe you try 10. Okay. So, never mind. We do try 10 now. Okay. So those that have done it already, so just bear with me or bear with everyone. Okay, you want to convert these to logarithm form. These are all in index notation, index form. So let's do this together. If I have 4 cubed equals to 64, how do I write this in my logarithm form? I will write log. Okay, what is the base? 4, right? What is number on top? It will be 64 equals to 3. Because 4 cubed equals to 64. Okay? What about part B? We have 10 to the power of n equals to 60. The base is 10, right? So I don't need to put log, base 10. We do our common logarithm, which is lg. Okay? Then base 10, power is n, right? So log 60 equals to n. So in fact, this is the way we find unknown. N is equals to log 60. Just that at this juncture, you may not know how to press into your calculator yet, because I have not yet taught you. Okay. Last one, e cubed, approximately 20.1. Let's just take it as equals, so that we can change it into logarithmic form. Okay, so in this case, the base is e, so I'll do my natural logarithm. I'll use ln. Base e equals to 3 power 20.1. So log 20.1 is equals to 3. Okay, questions? Okay, now that we practice changing to log form, we look at try 11, changing to index form. Log 0.5 base 2 equals to negative 1. How do I change this into index form? Log 0.5 base 2 equals to negative 1. Change into index form, what would it be?
0.5
2 to the power of negative 1 equals to 0.5. So always start with the base. Okay? That's personally my habit. I always recognize the base first. Part B, if we say log 148 equals to 5, what do I write? E to the power of 5 equals to 148. Okay? And then the last one, the base will be 10 to the power of 4 equals to P. Okay? Questions? Anna? If no questions, let's try more. Okay, I want you to practice on your own. Okay, exercise form. And then question 7, convert to index form. Okay, I'll just give you 3 minutes to do. It really shouldn't take you forever. Change. Should take you 10 seconds for each question. Okay. Let's call some names to check. Ari, can you tell me part A? What is it that you wrote? Non. K
Equals to 2x.
equals to 2x. Do you all get it? Okay, great. Megan, can you tell me part B, what is the answer? Log 9 base 10. So you will write intention base 10? No need, right? Okay, so it's just common log equals to x minus 4. Okay, so we write this. Right? Then part C, Nash, what you get? Sorry, what do you say?
X equals to log base 4
X equals to log base 4 2 minus k. Like that. Is it? Okay. You agree? It's just in reverse. Okay, so base is 4. Over here, power is x. Okay, this 2 minus k, please make sure there are brackets. If without brackets, it means a different thing. Okay, what it means is that we are taking log 2 base 4 followed by minus k. Whereas with the brackets itself, we are looking at log 2 minus k base 4. Okay, so the brackets are very critical. It changes the way we look at the equation itself. And then part D, Renee, can you tell me what you get? Ln bracket n minus 2 equals to x plus 5. Agree? So the base is e, so we should use our natural log. Base e, power is x plus 5, n minus 2 over here. Okay? Question 7. Isaac Yuan, can you tell me what you get? 3 to the power of equals to 1. Great. And then part B, Melody, can you tell me what you get?
E to the power x minus 3 equals 1.
Yes. E to the power x minus 3 equals to 1. Okay. Then part C, what do you get, Joven? X square or 10 square equals to x minus 1. Great. And then last one, Janelle, can you tell me what you get? Okay, great. 2 to the power of p plus 1 equals to 4, 1. Okay, so I hope that you are familiar with changing between exponential and logarithmic form already. Tomorrow we will touch more on the definition of the logarithm itself, and then followed by introducing to you all the different rules and laws, okay, which is going to be a whole new world to all of us.